Let's now prove this theorem that if a is a real number and z is complex, then a times z conjugate is the same thing as a times z conjugate. This theorem is needed to prove the conjugate root theorem for finding the complex roots of polynomials with real coefficients. To get the proof of this, let z be equal to b plus ci. The letter A has already been used, so let me use two other letters, B and C, where B and C are both real numbers. So let's start with the left-hand side, A times Z conjugate. Well, A times Z will be just simply A times B plus A times CI, just multiplying Z by A. Now, because A is real, A times B is real, and also A times C is real. So because A is real, I can write this as A times B minus A times C times I, because A is real. Then I can factor an A out for B minus C times I. And then the thing in parentheses is simply going to be Z conjugate all by itself. And so the net effect is that the A comes out of the conjugate, and so that ends the proof. An alternate way of proving this would be to use the fact, well, let me just write it around, proof number 2. A times Z conjugate by a previous theorem, that's equal to A conjugate times Z conjugate. And the conjugate of a real number is always itself, and so the A conjugate is simply A, and that would also be a perfectly valid proof, assuming that this first theorem had been proven earlier.